Compound events. When looking at the likelihood that two or more events will occur, it is called a compounding event. And so when finding or probabilities, what we do is we find the probabilities and then we add them together. And then when we're finding and probabilities, we then find the probabilities and multiply them together. So let's go over an example. Example 1. In a shipment out of 500 bulbs, 5 bulbs were broken and 7 did not work. What is the probability that a bulb was broken or did not work in that shipment? So when looking at this problem, we notice we have an or probability. And so when we have an or probability, the first step is to find both probabilities that we're looking at. So we have broken and then did not work. So out of a shipment out of 500, 5 bulbs were broken. So we go 5 out of 500. Let me go put broken here. And then did not work. We see that there was 7 out of 500. So now we have found both probabilities, and then because it's an or, we know we need to add them together. So we go 5 out of 500 plus 7 out of 500. So because we have a common denominator, we can just go ahead and straight up and add our numerators. So 5 plus 7 is 12. So now we have 12 over 500, but we want to reduce that. So let's go ahead and reduce the top and the bottom both by 2. So we get 6 over 250. We'll say reduce, so we know. And we will stop right there, and that is our probability that either a bulb was broken or did not work in that shipment. So let's look at another example. Example 2. In a shipment out of 100 bulbs, 3 bulbs were broken and 2 did not work. What is the probability that a bulb was broken or did not work in that shipment? So we see that we once again have an or statement. So when we see an or statement, that means we need to add the two probabilities together. So the first step is to find them. So the first one is 3 bulbs were broken. So we would put 3 out of 100 because there's a total shipment of 100. And then 2 did not work. So did not work. We can label it. And then we can put broken. The next step is then, since we found them, we need to add them together. So we got a 3 out of 100 plus, and then this one needs to be 2 out of 100. We have a common denominator, so we can go ahead and straight up and add our numerators. So it is 5 out of 100 were either broken or did not work. Now 5 out of 100 can be further reduced. So we can divide both the top and the bottom by 5. So we get 1 out of 20. And so we would say 1 out of 20 either was broken or did not work in that shipment. So let's do one final example. Example 3. In a given week, Evergreen Electrical Company had 85 residential service calls. 6 of those residential calls had circuit breakers keep tripping due to too much current being drawn. 9 of the service calls were due to lights flickering. What is the probability that the residential service call had circuit breakers kept tripping and lights flickering. So for this problem, we see we have the AND probability. So our first step will be, like before, is to find both probabilities. So we have circuit breakers tripping. So we see that we have 6 of the total were due to that. So we would say 6 out of 85. The next thing we're looking for is lights flickering. And we would say 9 of them were out of the total, which is 85. So now we found both probabilities. And the next step would be is to multiply. So we would go 6 over 85 times 9 over 85. So we need to multiply out these numbers. So let's get our calculators out. So we go 6 times 9, which is equal to 54. Our next step is to go 85 times 85, which is 7,225. Now, we can just go ahead and circle that because it cannot be further reduced as there is no multiples within to reduce it by. There is no common multiples between 54 and 7,225. So we would say that the probability that the residential service call had circuit breakers keep tripping or the lights were flickering was 54 out of 7,225